spanning the globe from all points in the universe. You can search, but you won't find anyone except this particular space geek. Casual Space with Beth Munn.
I've been enjoying talking to Miss Natalie. Hello, Natalie.
Hi, how are you?
I'm so happy to meet you. I've enjoyed your book so much. We were just talking about it. I'm glad it's everyone who's listening, every member of your family or your students, or anyone who has any interest in either the universe or our world here on Earth will love your book.
Thank you.
It was
Thank you
great.
so much.
You know why I loved it so much? Because like this show, I didn't feel overwhelmed with a lot of like technical references or details that got me lost. As a matter of fact, I felt inspired and educated because you came to it with so much awe and wonder about asking these big questions. But unlike, say, the Fermi paradox or some of the equations, this was just a very wonderfully inviting invitation to look a little deeper and ask these big questions. And you tackled them with such grace and beautiful poetry. Can I quote you my favorite quote? Or maybe on about the sparks of life and of the whole book. This is what I love. Being unique does not mean being alone.
And it's, I think so.
It goes on the next page and it says, let's see if I can grab it here. I need two pairs of glasses, one for the computer and one for Natalie knows. Our search for life beyond our planet is guided and possibly limited by what we know from Earth. But this is all we have to get started on our quest to look at Earth in order to look into space. Oh, Natalie. So where should we start?
Maybe from Earth? I don't know. This is a good starting point.
Well, let's start with you. How did you become so interested in studying astrobiology?
Well, often people are asking me because there are many ways you can develop a passion. And I am absolutely clueless. If I trust my mom, she said that's basically the first thing I said. I didn't say it, but I said that very early. I was pointing to the stars and I was always very interested by it, by all these questions. So astrobiology didn't exist at the time. That was astronomy. But I am like the little black swan in the family. Nobody was doing this before. I am a swimmer. I'm a diver. I'm a mountaineer. That doesn't run in the family. So I had to ask her if she bought me at the supermarket or find me somewhere. But it was always with me.
Yeah. You have that curiosity and adventurous spirit. I can tell. When was that in your yard or was it in school or was it through books? How did it become satiated? Like, how did you encourage that curiosity at first?
Again, mom, ever present mom. We were not that rich at all, but the little pennies she could put aside, she would buy me books or magazines. And we talked and she always encouraged me. So with her, I really always found somebody I could lean on. It was not always easy because some of the things I wanted to do or I thought about at the time didn't even exist. I mean, it's obvious for everybody today that there are exoplanets, that we are, looking for life in the universe. When I was born, the first spacecraft were starting to be sent in the solar system. Pretty much all the knowledge we had was from ground space telescope, if you can imagine that. I am not that old, but this is how fast the discipline has been going. So the idea of life in the universe was mainly associated with science fiction, when I was born. And it took people like Carl Sagan to all of a sudden wrap this notion and leave the romance to bring it into the science.
Sure. What a wonderful mom. I'm glad to hear that. That
Oh, yeah.
sounds lovely. Good. That sounds fantastic. Did you have a challenge or any difficulty struggling from what you wanted to see out in the field and outside in our beautiful landscape and earthscape, and then having to do the work in the lab? Like, was that a challenge to have to be focused inside and at the, the sciences and get into the studies, but also exploring? How did you work that balance or
No,
challenge?
it was so funny because I never had a straight line. Just because what I wanted to do didn't really exist, I didn't go from point A to point B. I knew what point B was supposed to be located. That was my passion and my dream. How I got there was definitely not what I thought, the path I thought I would be engaging into. In fact, many times I thought I was going 180 degrees to where I really wanted to be. But when I look back today, I said, this is exactly the path I needed for me to be, where I am today and doing the things I do. And you can look at this, both ways. Says, well, you are the person you are because of the path you took, or maybe you were guided to be doing those things because of a path that was not the one you were expecting. So for me, that was a long, winding road. I wanted to be an astronomer, but guess what? I was not good at math and physics. So I went through earth and environmental sciences at the Sorbonne to start with, well, at Nanterre to start with in France. And it's a blessing. At the time, for me, it was just like, okay, I have to choose something. And if I have to learn about planets, I'm going to start with ours. And if this is the only thing I can do, at least I will be dealing with our planets. So I started with climate and hydrology and environmental science until planetary sciences started to be established and popped in France. And I was the first woman doing a master thesis and then a PhD thesis in planetary sciences. But the thing is that at the time where I really finally released, everything to the universe, literally, and saying, I need to engage myself into something that was not what I wanted to do, but was the closest. Well, a couple of years later, somebody came on my path and say, would you be interested in meeting that professor at the observatory in Meudon? Is interested in something that I think is new, called planetary geology. The person who said that was the professor of the lab I was in, very happy to be with, who was supposed to be my advisor for my master thesis in environmental sciences. And he said, you can meet him. He's a good friend. You can have a chat. And of course, I was begging everybody with my passion for astronomy. So they all knew. And he got me that meeting. And basically 24 hours before signing my master thesis in environmental science, I met with that professor at the observatory of Meudon, and I came down the observatory 9 years later with a master and PhD thesis in planetary sciences. This is where, call it whatever you want, fate, destiny, or just not giving up. This is when things start to happen. And after that, it was a series of intersections. And as my husband was saying, be always aware of those intersections in life. And that was it. It took leaps of faith too. I mean,
Sure.
a series of them. And the one that took me here in the United States was a very serious one that was, that for me meant leaving everybody behind. My family, everybody I had known or grown up with. And I left with the person who was going to become my husband, was taking a pretty big leap of faith too, because of the difference we had in age. I could have met anybody younger arriving here. He had left everything behind. So, yeah, that was a very long response to your question, I
Oh, I
guess.
love it though. And I was thinking along your journey, and for so many females, especially women who they know where they want to go. And if there's not yet a path or a first woman or a woman leader or a guide or someone who's carved that, then they just keep going until that path is carved. And that certainly sounded like that was your experience, because when you're passionate about where you want to explore and become, you just kind of find the way. It sounds
Oh,
like you just
yeah.
keep going.
Absolutely. And again, looking back now with time, there is something to be said about being passionate. It's a long, hard road because you know that what you have within you is so strong that it's worth all the hardship you're putting yourself. But at the same time, opening paths means something is that you are going to be the first to see that landscape. And there is nothing that beats that.
Oh, being the first. That's right. Oh, my goodness. So well said. And I know it must have been so hard to leave your family, but it must have been tugging at you to say, if this is my passion, this is where it's leading me, and I must go there.
Oh, no. And, um, it was hard, but I always thought, especially in time and being, the only child, having this such a great connection with my mom. It came later with my dad, but we were very, very close with my mom. I always felt the only sadness, the only regret is that the sacrifice was so much bigger for them. I mean, you have you have children, then you do what you need to do for them, but you are sacrificing a part of your life. I mean, the sacrifice, you don't want to call it that way, of course, because you are invested completely in your kids, but it's a continued sacrifice. But you can think that maybe in time, they will come back and you will have grandkids and you will have, and it happened so that, well, I can tell, my mom sacrificed everything. Everything she had, she put it, for me towards my dream because she couldn't pursue hers, and she knew how it felt. So, but ultimately, she had to sacrifice that too, which was my presence near to her. And so, we managed. But certainly today I still feel this is something that I'm wearing. I'm really wearing it, especially since, she left this year. And I just cannot tell, maybe the two of us, she was the greatest spirit.
Oh, what was her dream?
Her dream, she wanted to be a surgeon. There was this kind of I don't know. I don't like the term curse, of course, but there are repeating patterns, that happen in family. Her father wanted to be a surgeon, but his dad passed away. There were 8 boys, and he was the oldest one, so he had to help his mom. Never got a chance to go to school, and we are talking about generations that were born around, 1910, 1920. So that was a different time there. And then when World War II came, he was too young to go into the regular army, and so he went into the French subway, resistance. And my mom was born in 42, and she adored her father. And then when he came back, he had a heart attack so bad that if he was today, he would probably have a heart transplant. But basically, he couldn't work anymore. Our mom was not doing so well at the time either, and so my mom was the older of 3 child. She went to work,
Sacrifice. Yes.
and
Sounds like,
it was a pattern, and she didn't want that pattern to repeat for me.
oh, but the science and that curiosity seems to have run through the family of
Yes,
the,
yes,
yeah, the
in
human
different
body and
ways.
how it works, the earth and how it works. And
Oh, well, my mom, she worked for decades as an X-ray technician, and my dad was working with
oh,
computers. So, the apple didn't fall too far from
no,
the tree. And I had a
that's
great
amazing.
grandfather who was a naturalist, but he was interested in everything, like, flowers and trees and animals and stars. So there's probably a little bit of all of those genes, and probably I brought them together, and who knows?
Probably.
Who knows?
I think so. Well, let's stay with I'm loving your idea of having so many firsts. And Natalie, you have so many. So I'd love for you to walk through. Can you give us one or two that either took your breath away or you saw a change in perspective in your life, whether it was your free diving or diving experiences of firsts, or your lab firsts, or the colleagues and first discoveries you've had together? Please share a few with
So
us.
I would say that me in the lab would be a first. I don't spend any time in the lab. I am not a lab scientist. And, oftentimes science is associated with laboratories and analysis, etc. I am a visual person, so I've been working a lot with imageries and, images, etc. So I would say that one of the first that I will never forget is definitely seeing Gusev crater from the ground when the Spirit rover landed, because my husband and I had been advocated for 15 years before that landing, for this site to be selected. And it was very present in our lives all the time. And all of a sudden, see it from the ground was very special, was extremely special. And then after that, you have to imagine for everybody who's listening and, looking at their iPad or their telephone every single day and looking at the images of Mars, like it's normal to have an image of Mars or an image of Jupiter, while you are taking your muffin and your coffee in the morning. Well, think for a second what it takes to get that image. And I got to be with the first rover missions. So the first was there. We got blessed enough with my husband to have the site we had been advocating for, Gusev crater, to be selected as part of the Mars Exploration Rover mission. And our backup site, Gale crater, is being explored right now by Curiosity. But not only there was that first, but that every single download of images. And believe me, I was there. The engineers invited me always in their in the engineering room when there was the download, 3:00 in the morning. It was different time every day because there is an hour difference every single day with Mars. But every single image that shows all of a sudden on that screen, you are the first human being to see that landscape ever, of 8 billion people on this planet, and now you have to figure out what it is. That's the science part, but the awe part of it is just to say, oh my God,
Yeah.
Obviously, the landscape in the Andes, certainly not the first one to see them, but maybe to see them through a different lens.
Yeah.
Looking at them because they are holding clues and keys about the history and the past of Mars. They are excellent analog. We call them terrestrial analogs because we are studying, aspects of the Martian landscape or environment that's so old, but also very similar to early Earth. And it's just like being at a time machine. So you are there and you are looking at the Earth 3.5 billion years ago and Mars 3.5 billion years ago and trying to figure out how life emerged from it. But also looking at the future, how am I going to explore Mars? And the reason we go there is because we need to understand what kind of habitat, microbial habitat, this environment can provide to life, and also how life resists to a climate change that's really fast. That happened on Mars. This is happening in the Andes as well. So you learn about those habitats, their signature in the landscape, and the type of instrument and the type of resolution that you need to detect them. And then you apply this to planetary exploration. So
this was so well said in your book, Natalie, because you went through each theory of how life could have started and the environment. And all of it, I didn't know. I may have known like one or two, like just general evolution and Darwin and how that might have happened. A little bit of panspermia ideas, but the other ideas that I got to learn were mind blowing. And I felt, like I said, so educated and inspired that I had to go back and sit with it. And I said, that really has a strong case. I really understand this, that how this could possibly happen. And you have another beautiful quote. And I don't know if it's from the theory that you're taking it from or from your own perspective, the way you shared it, but the inevitability of life theory. I love that one. Can you explain that one?
Yes, and that's not my quote. This is Jeremy England's quote, and Jeremy is actually taking on the work where Schrödinger left it.
Oh,
In 1942, Schrödinger was working on a number of things. One of them was the origins of life. And it was coming not from the biology standpoint, but from the physics and biophysics standpoint. And I find it extremely interesting because right now, with what we call the origins of life, which, we have very different theories about that. The only difficulty with an origin of life is that we are bottlenecking ourselves in our search because there is only one data point that we know of. That's ours. So we need an environment that's like ours, and we need life that has a biochemistry that's fairly similar to ours. And this is not stupid. It makes a lot of sense because now we have discovered so many exoplanets where the environment obviously, is not identical to the Earth. Even if you have trillions of planets in the universe, no one is going to be identical to the Earth. It took too many stochastic events and for this to happen. But similar enough that the life that we know could live on it. But ultimately, and two, the bricks of life, what we call the bricks of life, which are, the elements that makes us, they are so very common. Right now, we even discovered, we thought that they were, heavier element appeared around 10 billion years ago when stars like the sun were starting to form. So GWST, the James Webb Telescope, is changing completely our perspective on that. We're discovering organic molecules like way back then, a few hundreds of millions of years after the Big Bang only, like 2 billion years old, maybe older. So it makes sense, the stuff we are made of is very common. It's not an accident. We are made of it because it's common. And so there is a good case to be made for carbon-based life in the universe. But still, that doesn't allow us, and that doesn't allow a mental space to think about other possibilities, life as we don't know it. And biophysics takes care of that because it looks at something that's more along the line of a universal marker, what we call the agnostic. I don't like the word, but it says what it says. You don't need to have a specific biochemistry for this to be true. And so what biophysics tells you is that life is the inevitable result of thermodynamics because it's the best way to fight entropy. And then here you have it. Entropy and thermophysics are two universal things, which means that there are two universal characteristics of the universe, how it works. It's a universal law. And so now we are looking at the nature of life. We're not looking at the origin of life. We're looking at life as a process, not as a thing. And I really like that because that gives us a different lens. That doesn't mean that looking at the origins of life, regardless of what it is, and we can talk about that too, is very complementary. But that's a new tool. And as far as the origin of life, I presented the different theories in the book. And once I listed them and started, looking into them, I sat back and I said, well, you know what? Right now, the two main competing theories, both of them are hydrothermal system. One of them is at the bottom of the ocean, the other one is on land, but basically they are saying the same thing. You need energy and you need water, and except that the one on land said we are better because we can have those cycle of wet and dry environment that's needed to create long chains of molecules for life. So, but if you are looking at everything else, theoretically it works. So I sort of started thinking, maybe all of them are right. Who says that there is one emergence of life on Earth? The only thing that we can say is that the life we know and we can recognize on our planet all goes back to the same unique ancestor that we call Luca, which is the very first, unicellular organism. The tree of life that we have on Earth goes back to. But other people, in particular Carol Leland and Paul Davis, they came back with, well, what about the hypothesis of a shadow biosphere? And then, the shadow biosphere is well, the possibility that maybe there is another tree of life, or there was another tree of life on Earth, and maybe it's still existing, but life is so different that is right in front of our nose, and we cannot tell it apart from the environment just because our tests are not designed to find it. See the problem of the biased experiment, and the problem of being both the experiment and the experimentator, the observation and the observer, right? Because it's really difficult to get yourself outside.
Which
I don't
goes
know.
all the way back around to Schrodinger.
To
Schrodinger, right?
Oh, to Schrodinger, yeah. And then the thing is that I don't know if the hypothesis of the shadow biosphere is true or not. As a theory, it should be verifiable or falsifiable. But what I know for a fact is that by trying to verify or falsify that theory, we are starting to learn to search for life as we don't know it. And yes, as you said so rightfully, the work done by Jeremy England and others, he's not the only one, but Jeremy is a pretty good advocate. And we don't know if he's right or not. This is very promising, right? But heading in one direction, again, science is not necessarily here to give you answer, but it's here to help you articulate better question. And no matter what you do, you see the universe in a different light once you're done trying to verify or falsify something. So you're making progress. We saw that again with the quote unquote Martian bacteria in the Martian meteorite. I was a very good friend with Dave McKay, who was a proponent of the presence of bacteria in the Martian meteorite. And I disagreed with David, and we respectfully disagreed with each other. And he asked me to give him some of the samples I had from the Andes to try and figure out, what fossils of bacteria could look into samples. But just to say, it's not that simple. You can have it right in front of your nose. We didn't know, we already are pretty sure that these are not bacteria, but it was not what mattered. Really, what matters is that it put us on a path to try and understand why we couldn't tell it was life or not life. And therefore, we thought about better instrument and better technology. And this is what's happening with exploration. This is sometimes frustrating to the public because, science fiction gives you answers right away.
Yes.
And, science is an iteration process. Sometimes we stumble into great discoveries. And most of the time we discover what intuitively we knew was there because we find what we are looking for, right? Real discoveries, the one that surprise you, are fairly rare. Yeah. But right now there is a new school of researchers that are thinking along the lines of this agnostic biosignature that would take care of biochemistries. And Jeremy is one example of them. You have Sarah Walker. She's looking at theory through physics as well. She's a wonderful, wonderful person. I love her work. And she's looking at it through theory and mathematics and statistics. And another one is Chris Campis. And he's looking at an expanded definition of life, where he's looking at patterns and repeating patterns, like societies and ecosystems and life and cells are all repeating the same patterns, which Mandelbrot, you know that through all of these fractal patterns that repeat from microscale to microscale. I am a firm believer that the answer to the question of life will come from there.
From the
It's
repeating
a
patterns.
I'm sorry.
From the repeating patterns?
Well, repeating patterns and agnostic biosignature. Repeating patterns are telling you something about something very profound about the process in the universe. Now, if Jeremy is right, I think that brings an interesting question, is that thermodynamics probably changes as the universe evolves. So are we seeing right now at this point in time in the universe just the right condition for life to emerge, or at least the type of life we can understand? So, I so enjoy, it took me, a lot of work and hurdles, etc., to get to where I am, but it's exactly the right time. There will be no other time in the history of humanity where we, there will be great discoveries, there will be turning point and pivots, etc. But we are that generation that escaped from the gravity of our planet, looked back at it with a fantastic, overview effect, and then started to change the perspective of us on one planet at the center of everything, from us looking at it and trying, hopefully, understanding that we are one on one world, and no boundaries and no politics and no colors and no races. From we are all blue from the distance, to then understanding that, well, our little planetary system is one of gazillions. So the more we go, the more we are decentered, but the more we are immersing ourselves. I think this is the thing. We are finally finding our true place, which in one but whole, and the whole has one. We are part of the same universe. So absolutely, completely enjoying this ride. But for the book itself, I so thought that it was time for us to have an overview, an update, because things have changed, And one of the issues as well in astrobiology is that although we have 4 or 5 decades now of new ideas and there are really less progress in terms of intellectual framework. And so I wanted to put this on the paper and start to think about it, because, well, I'm coming from the Sorbonne, so I like epistemology and questioning the question. But at the same time, it's been a joy to write this book, and it's been a nightmare, because every time I was finishing a chapter, of course, something was being discovered and I had to modify something. The background story is that I asked my editor in France. It was published in France a year, before it was published here in the US. And we were waiting for the DART, the DART mission on the asteroid, the impact mission. And so the impact was there. And I said to my editor, excuse me, I told him, I know, because we have citizen science going on, we'll have the results faster than we imagined, that were supposed to come 2 months later. Say, give me another week. And say, okay. And guess what? 2 days later, we had a result that indeed we had modified the orbit of that little moonlet. Mm-hmm. So anyways, it was an adventure.
things are happening faster than you can
Yeah.
write them and update your book. It's a never
Well, I
ending.
mean, from the editing standpoint, that's probably good for,
Yes,
second and third editions. I don't know.
right. You bet. That's why I highly recommend it because I always appreciate when you can come into something with a curiosity and learn so much from it without feeling overwhelmed or that you have to read it again or go off and do another examination of the words or the references. Just appreciate that. And I know that our audience and listeners do as well. I've been so wanting to ask you this question. When you are an astrobiologist and you're asking the big questions in the universe, how does that digest for you? Because for the rest of us, and you do too, you have to go shopping, you have to pay bills, you have to do human survival basic things. But you are looking through the universe with a different lens and perspective. You operate, I'm being assumptuous here and please forgive me, but because you can look through space and time and geology through what you're studying and examining, you do perhaps have that different perspective than most of us. And when you sit with that and really contemplate, is that overwhelming? Is it freeing? Is it hopeful? Is it exhausting? Do you feel like, how do you digest this? Can you help us, the rest of us, navigate this? Because it, it's immensely overwhelming to, I think, the majority of us who are not able to sit for long periods of time and understand how a simple rock can hold so much information in our pocket on this planet that can also mirror and gateway into a whole nother rock in another universe, in another place in time. Am I asking the question properly? Because I feel even
I
overwhelmed
don't think
asking
there
it.
is any a wrong way of asking that question. You ask it in the way you feel it, and so this is your way. It's not a wrong way.
Okay.
It's your way. I'm going to answer with one word and then I'll expand. Um, to me, what this does is it gives me a lot of peace. And I'll go to Carl Sagan, saying that science is a great source of spirituality. And definitely it gives you a chance to look at things with a different lens and at a different scale. When you are taking that rock in your hand, with all of its history, and it's a humbling experience because for many reasons. For the memory this rock contains, also telling you that this rock was formed, I don't know, 200 million years ago. And then you compare your moment, on this planet. And that puts things into perspective. And what I like, especially with astrobiology, is that you can look at planets from above. And this overview effect that the astronauts are talking so much about is this huge revelation of our true dimension. And it's not to diminish the human dimension. Remember, we are infinitely small at the scale of this planet or the universe, but you are infinitely big because you have the ability to sit and look and try to understand the vastness or the meaning. If we are lucky, we're trying to dig a little bit into the meaning. And there is this quote, and unfortunately, I don't remember who said that we are not physical being having a spiritual experience. We are spiritual beings having a physical experience. And I think that, working through astrobiology, you can take that quote and take that rock and understand exactly what that means. Because all of a sudden, is just like everything that's around you is a way for the universe to manifest energy into the physical world. And if you look, even through the ugliness of the world right now, it's still a symphony about the potential of manifestation and our free will to go one direction or the next. Yeah, we are messed up right now. You know, it's I said somewhere in the book, we're a teenage civilization, and we are caught up in our ability to manifest. And what I mean by that is that what is born in our brain, we create with our hands. What you see is the power of our thoughts being manifested. The world around us is the manifestation of the power of our thoughts. And the planet we live on is the universe manifesting energy into matter, right? This is how it works. You're bringing molecules together. I'm not having a spiritual discussion right now, unless you think that this is spiritual, which you can think too. But energy is manifesting into matter to create planets, to create stars, etc. And life emerges from it. We don't know if it's a transition. Transition may mean nothing because we don't know where it starts. So maybe there is no transition. Life is another manifestation of the universe that has this possibility, this ability to look back at this manifestation and to create too. So right now, our civilization is caught in the process of creation. We're creating stuff to create stuff, and the more stuff we have, the more stuff we want to create.
Yeah.
And in doing so, we are completely disrupting the balance because we are part of a biogeological cycle. And then I'm going back here to the nitty-gritty details of biogeophysics, which is that all of us, matter, living matter or non-living matter, we are made of atom. Remember the beginning of our discussion? And at a level that is not perceptible to, our human eyes, these atoms, whether they are alive or not alive, they interact all the time. This is what we call coevolution of life of the environment. And the world, before we started playing a little too much with it, was kept in balance through those cycles. And at that point, we are messing up too much of this balance. And that goes back to Jeremy England's thermodynamics. Life can be hot, but too hot is not too good. So what I'm trying to say here is that the perception is one of oneness. And that when you're working the questions that we are working on astrobiology, you have to stop looking at life and environment as being separated. Whether it's on your planet or in the universe, everything we do, there is a complete connection. Everything to everything, everywhere, all the time. Even when I push, remember, if a butterfly flaps the wing here, but that's true.
It's true.
Because
and that's what brings you the peace.
What brings me to peace is that there is a sense of balance somewhere. And it that keeps you humble too. Because if you look in a very detached fashion about this, say, okay, there is the human experiment. And the human experiment has been around for a few million years. The dinosaur experiment went on for 150 million years. We're not even, close to that. But nature has a way of balancing the books. And she doesn't care about who is where and when and what. Nature is going to balance the book. And if we want to move on to the next stage, which is, a long-term adult civilization, we better understand what it means to balance the book. Otherwise, we won't be part of the next experiment. And you can look at this in a way of saying, the planet is in no danger whatsoever. What's in danger is our environment, the one that was favorable to us. But again, I am drifting a little bit here from your point, but there is peace. There is a lot of spirituality, a lot of humility in this look, and a lot of love.
Wow. So profound. Natalie, I could talk to you more and longer, and we didn't even get into the details of some of the wonderful things in your book and your experiences and all the things that you've done. We've just touched the surface. And so I have to ask you, once everyone hears this and gets through your book and gets their copy and gets to read it, will you please come back and maybe share some more questions and talk with us again? Because this was such a pleasure.
Oh, absolutely. Thank you so much. The issue with that is that obviously, as you could witness, it's not difficult to get me started. It's a lot more difficult to get me to stop
I
talking.
don't mind.
So, no, it would be a great pleasure.
Oh, so many questions, Natalie. People are going to ask about what we're going to do with the Mars return samples and the Venus, the Rocket Lab Venus samples that are going to come from the clouds and bring back those samples in the near future. These are all, we want to hear your perspective and what you
Yeah,
think of these.
absolutely.
And but I want to let
These are
people
the
digest.
detail, the detail of the thing. Absolutely. I'd be thrilled. I'd be really happy to do that. What I wanted to say is that the secret life of the universe is, for me, a way to say to the public, here is how far we have come, and we are, going beyond every single day. But look at how our vision of the universe has changed. And because astrobiology is a mirror and allows us to look back at the Earth through that mirror, how much more we understand, or we should understand, about our place on that planet. And it is time for us, it is, I wanted this to be a reflection. I wanted this to be a conversation. That's why I really tried my best to make it, easy for people to understand and keep this a conversation. I'm not trying to convince people with my views when it comes to, a more spiritual angle. One of the best discussions and conversation I have is with the director of the Observatory of the Vatican. He is a member of the Science Advisory Board of the SETI Institute, and I have the chance to talk with him all the time. And the two of us share a very similar vision. We don't see any contradiction. I often say that science is trying to explain nature by measuring it, and spirituality, well, try to explain everything that we cannot measure. So it's just two visions. As long as people get along and don't try to convince each other that their views is better than the other, I think that just as like your opinion, your question, just a reflection of who we are and our way of questioning. So it's fine. But let's go into the nitty-gritty detail of exploration next time we talk.
Yes. Oh, well, that would be wonderful. Everyone will enjoy that. We can't wait. Thank you so much for your time. I'm going to invite people not only to get the book, but if they have questions, please send them. And when we talk with you again, I'll have those ready and we'll enjoy another conversation. This was such a pleasure. Thank you so much for making this book.
Thank you very much, Beth. Thank you for inviting me.
Anytime. We'll see you again soon.
If you haven't already geeked out enough, there's much more at casualspacepodcast.com. There's more on the Facebook page, Casual Space Podcast.